Hello everyone, this is Ashish, student from National College of Ireland. I am here to present a short video on my data warehousing and business intelligence project on Airbus Aviation. For this project, I have used datasets from three different sources, of which two are structured and one is unstructured. The first source is Statista, which provides information about the leading airline companies within Europe and the average price of Airbus aircraft models in 2018. The second source of structured data set is Wikipedia, which provides information about the details of Airbus aircraft and order details of different Airbus models by airline companies. The third data set I have used is Twitter, which is an unstructured data source. Using Twitter API, over 170,000 tweets were extracted on which sentiment analysis was performed. Moving towards SSIS, this is how ETL process for our data warehouse looks like. Let's start the ETL process by clicking Start button. As we can see, we are truncating the existing raw tables using SQL task in the first step. The ETL process in SSIS is divided into 5 sequence containers. The first is raw data container, where we have 5 process tasks. Each process task executes their respective R script, followed by data flow task to load data in raw table using flat file and OLE DB destination. So for this particular task, we can see 128 rows were added. Second container is drop fact and dimensions, where we are deleting the existing fact and dimension tables. Deleting fact table is necessary as we cannot delete existing dimension directly, as the fact contains dimension table columns as foreign key. Third is the dimension container, where we are loading data into our dimension tables using execute SQL task. Next is the fact table container, which is responsible for loading data in our fact table. And last is cube container, where our star schema is generated followed by cube deployment. All these processes are fully automated. Now let's check our star schema that has been generated. So this is our star schema with 3 dimensions that has been generated. Now let's move to Tableau for visualizations. So here we have Tableau with our first BI query, that is which type of aircraft is most popular among European airlines. In the heat map, we can see that A319 and A320ceo are the aircraft with maximum order values. The cost for A319 is $92.3 million and A320 is $101 million. And looking at the flying range for these two aircrafts, we can say that European airlines prefer airplanes that cost between 92 to $100 million with flying range of 6 to 7,000 kilometers. Our next query deals with common destination cities among European airlines versus type of aircraft operated by them. In the map, we can clearly see that most number of common destinations are within Europe region. Similar to our previous BI query, we can see that A319 CEO and A320 CEO are the most popular aircrafts in Europe with flying range between 6 to 7,000 kilometers. This implies that as most number of common destinations are within Europe region, the requirement for such aircrafts are high among European airlines. Our third query is sentiment analysis on flying hubs of airlines. We can see that the positive score for every location is higher than its negative score. This shows that people have more of positive experience than negative with Airbus aircrafts. Thank you for watching.